Okay, in today's video we are going to learn about the law of cosines. Now previously we learned about the law of sines, and we learned that when we were given one side and two angles, so when we had either a scenario of angle side angle or angle angle side, there was always one triangle possible. And when that happened, we set up our law of sines ratios and we cross multiplied to find what we needed. Then we learned the next day about our ambiguous case, and the ambiguous case means that there's not necessarily always one answer. There could be no triangles, one triangle, or two triangles possible, and we recognize this in our side-side angle scenario. And what we did was we started solving with law of sines, and then one of two things could happen. If we ended up getting that the sine of the angle was greater than 1, then that meant that there were no triangles, because it's not possible to have a sine of an angle greater than 1. If the sine of the angle was less than 1, then there were two scenarios that could happen. If that second angle that was found was greater than the given angle, there are two triangles. If the second angle found is less than the given angle, then there's only going to be one triangle. And that's what we worked on for the last 2 days. Now what we're going to do is we're going to take a look at another formula called Law of Cosines. And Law of Cosines is good for us when we have either two sides or three sides of our triangle. So Law of Cosines we will use when we are given a side angle side scenario, and this is different from the other one. In this case, this is the included angle. So for example, side angle side, or if we are given three sides of a triangle. And as I mentioned the other day, it's always helpful to sketch the triangle so that you know what exactly you're working with, so that you don't confuse a side angle side with a side angle scenario. Okay, so this is what our Law of Cosines formula looks like. And as I mentioned the other day when we saw multiple versions of the same formula, it's not helpful to just blatantly memorize them, because if the problem that I give you happens to be, for example, triangle X, Y, Z, then you're going to be in trouble because you're not going to quite know what to do. So when I look at this formula, to me, it totally reminds me of a side angle side scenario. So let's take a look and just focus on this top formula right here. If I label this as angle A, triangle ABC, and this is side little c, little b, and little a, I'm essentially saying that in order to find this side, I'm going to square this side, and I'm going to use the cosine of the angle across from it. So essentially, whatever side you're trying to find uses everything on the other side of the triangle for it. So when you're trying to look at the formula, just think of it like that. Another way that I've heard people think of it is that whatever letter is over here is the same letter that they see over there. And then the other two letters, since you're adding and multiplying, the order that you write them doesn't matter. Okay, so let's go ahead and take a look at how this formula will get used. Okay, sorry about that. Okay, so in this first problem here, we are given angle A, side B, and side C. So let's start out by drawing ourselves a quick sketch to see what we're working with. So if we draw our triangle, A, B, and C, we are given angle A, we are given side B, and we are given side C. So notice you don't even really have to write them in, just necessarily recognizing that yes, this is in fact a side angle side scenario. So when we have a side angle side scenario, our strategy is going to be to use law of cosines to find the missing side. So the side that I'm trying to find is A. So I'm going to start by saying A squared equals, and then now I use the other two sides, B squared plus C squared. I subtract double their product, minus 2BC, and I multiply it by the cosine of angle A. So now I've got my game plan. Now I'm going to go ahead and write down my formula with the actual numbers from the problem. So A squared equals 2.78 squared plus 3.92 squared minus 2 times 2.78 times 3.92 times cosine of 41.4. All right, let's go ahead and plug that in our calculators. Okay, after... Honey, can you let me finish my video, please? Okay, so after we go ahead and type that in our calculators, then we get that a squared equals 6.74597, and don't forget to square root that. That is a very common mistake. And we end up getting that a is equal to 2.597 centimeters. Okay, so now we know all three sides in our triangle. Now we need to use law of sines to find the smaller angle. Now you might be wondering why it matters. This is a very important detail. There are two unknown angles left, and it's possible that one of them is obtuse. So if we use law of sines to find the smaller angle, we are guaranteed the smaller angle is acute. And by doing so, if there is an obtuse angle, we will find it when we do the last step and subtract from 180 to get the third angle. Okay, so we'll say the sine of angle B over side B equals the sine of angle A over side A, the answer that we just found, and then we cross multiply and do our inverse. We end up getting the angle B equals 45.065 degrees. And then lastly, to find our third angle, we can go ahead and we can take 180 and subtract our given angle, subtract our second angle, and we will get our third angle C to equal 93.535 degrees. And as you can see, if we would have found angle C first with law of sines, we would have gotten it wrong. And the reason why is because when you do sine inverse, you always get an acute angle. The calculator would not have given you the obtuse angle. And so if we always follow this procedure of finding the smaller angle first when there are two unknown angles, we will be guaranteed to get the right answer. All right, let's go ahead and take a look at our next example. In this case, you want to solve a triangle where we are given three sides. So this is our side, side, side scenario. Now with side, 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 we have to find one angle. And the angle that we're going to find is the largest angle. And it matters which one you find. The reason why it matters is because we know that with cosine inverse is going to give you an answer that's between 0 and 180. So if an obtuse angle exists, your cosine will find it. All right, hold on, I have to pause the video again. Uh-oh, what happened there? Sorry about that. Not only am I sick, but my daughter's also sick, which makes for a rough day. Anyway, so we want to go ahead and we want to find the largest angle. And the reason why this is so important is because recall that cosine inverse. Okay, again, I apologize. This video is spazzing on me. Okay, let's get down to business here. So we want to go ahead and find our largest angle. Based on our three side lengths, we know that angle C is going to be the largest angle because it's the largest side. So I'm going to start with a formula that has angle C in it. And recall that angle C is going to be the formula that starts with C squared. So C squared equals A squared plus B squared minus 2AB cosine angle C. All right, now since this is essentially what I'm trying to solve for, a lot of times people find it helpful to first rearrange the equation and get the cosine of the angle alone before they plug in the numbers. That's kind of up to you in terms of what your preference is. However, if we were to do that, we would say we would need to subtract the A squared over, subtract the B squared over, and then divide by the negative 2AB. So we would have that C squared minus A squared minus B squared all divided by negative 2AB is equal to cosine of angle C. And that's what you would want to plug in the calculator. Okay, now if we do that for our problem that we have here, we have the numbers, we would have 36 minus 9 minus 25 all over -2 times 3 times 5 equals cosine of angle C. Okay, so we would plug this in the calculator. And let's go ahead and type this in. And then you want to do your cosine inverse. And we end up getting that angle C is equal to 93.823 degrees with rounding. Okay, and again, this is another advantage to law of cosines. Law of cosines helps you find that obtuse angle because it does distinguish between the acute and obtuse angles. Now, I need to find 2 more angles. Now that I know I found an acute or an obtuse angle, I know there are no more obtuse angles. So now I can go ahead and use law of sines, which is our easier function to work with to find those other 2 angles. So go ahead and complete the problem to find angle A and angle B, and you should get the following 2 angles. Okay, last up is Huron's formula. Huron's formula is another way to find the area of a triangle when you only know 3 sides of a triangle. Essentially what you need to do is you need to first find what's called the semi-perimeter, and then you take the semi-perimeter and multiply it by the semi-perimeter, subtracting each of the sides. So if we were to go ahead and do number 3 together, we would first find our semi-perimeter. So we would do half of 4 plus 7 plus 6, which would give us 8.5. And then to find our area, we would do the square root of, and then we would do 8.5 times, and then 8.5 would just subtract each of these numbers. Oops. All right, go ahead and finish these 2 examples. Pause the video. All right, and as you can see, number 4 is not possible. These 3 side lengths don't even make a triangle because the rule is that any 2 sides must add to be greater than a third side, and in this case, that is not possible. All right, I know that this video is not the best quality, nor is my voice. However, it's better than nothing. Good luck with that. Check your answers on your homework and help each other out. All right, that's it.